Hello guys. So in this video we will plot our function to both functions which you saw in the last video. So in this video we will be just going and plotting the graphs of those functions. We will see the time taken by them when the n grows. We saw in the video there were like two functions. The one function which had only 3 operations to perform, one liner inside block code, and the other function which had 5n plus 2 operations to perform. It was n dependent and other was not n dependent. So the one which was not n dependent, that if something is not dependent on something, then it is more fast and like stress free. Like my friend, if my friend doesn't have a girlfriend, he is stress free. If I have girlfriend or girlfriends, then I'm more stressed. I have more work to do. So he is faster and I'm not that faster because of I have more steps to do. So we will see that. Oh, and one more thing. So basically I was following a lecture. I don't know what the teacher's name is, called Steel. So in his video, in order to visualize the time space complexity, or time complexity basically, not space complexity, sorry, the time complexity. So he has created one application or whatever you call it, a website in which he was doing the plotting of the graph, but I did not have anything so that I could use to teach or show in this video because the code for that he did not do public. So I didn't use my brain, to be honest. I just chat GPT'd it, and chat GPT was not even easy. It took like 1 to 2 hours or 3 hours actually. It took a lot of time. If I was a good developer, I could have just created it on my own, but I'm not that much good. Don't know shit about developing things like that, but I managed it. So I got somewhere closer to what he was having there in his video, that visual representation of the time complexity, the performance tracker, like use a function and start plotting. So in that thing, so I have made something similar. So let's jump into the video. Let's go, guys. Oh, I don't have to do anything. Okay, so let's come on the screen. And so this is our let's say this was our, wait a second, so these two are the functions. This one was n dependent, this was not n dependent. Okay, so we'll plot both of them. Oh, by the way, the tool which I was saying, which was there, was this one. This was his tool. It's very good, and I tried my best to make it appear like this, but I don't even know the terminology so that I can drop it into my chat GPT wala performance tracker. But whatever, this is what happened. Okay, this actually does the work, actually, I'm not joking. So herein you have to put in the function. Okay, so let us put our first function. Let's put the not n dependent function, this one, not n dependent function, right? Copy it and paste it here. As you can see, it has been pasted. Okay, now let's name it not n dependent. Okay, and we will first start with the value 0. Okay, with the n value of 0, we plot it. So you see, when this side is n, okay, the x-axis is n, so when it is 0, so it is taking nothing, no time at all. It is here, right? Okay, so let's increase n to 10. Update. So it is taking time, I guess. Oh, I need to add the graph. Sorry. I need to add the graph. So not n dependent. Okay, so it is, as I said, it is 0, and time taken is no time taken. It is just flat on the axis. It is just flat on the axis. Okay, so we will add okay, where did you go? Oh, it is here. Anyways, it's a lot of confusing here because it's not visually that much appealing. So now you can see, when I put n values as 100, time taken is 40 microseconds. 40 microseconds. And when I put it to 100, still 1000, it's still the same. Oh, it's gonna take some time. Oh god, it is taking seconds. How much seconds? 0.005 seconds. And when I make it a bit, let's make it 1 million now. 1 billion now. 1 2 3 1 2 3 1 2 3. Take some time because in the background there is a library that is being used. So it is taking around something exactly between 0.005 and 0.006 seconds. Let's increase a bit more. Let's add 3 more zeros. It's getting more close to 0.006, but it is kind of constant only. It is not increasing that much. Again, I increase the zeros. Let's see. So you see, it's just it is just between 0.006 and it's not even increasing. It's increasing it like anything, but the value is staying constant. It is not increasing. Sometimes it is taking a lot of time, sometimes it is happening quickly. So it is staying constant between 0.005 to 0.006. It is the case of in which where we have this not independent function. Now let's add in another function inside this, which was our this function. Okay, we copy it. And by the way, the code implementation of this visualizing whatever this thing is, which is being created by the ChatGPT is, I don't know, bro. I just copied and pasted it here. Hopefully it is getting recorded. Let's see. Yeah, it's getting. So yeah, so we'll say independent. Okay, and we'll start with the first 0, right? Add a function. Should give another color. It should give. It's taking time. As I said, it's based on a library. So yeah, can't even see it, I guess. Let's just remove this one. It's not even there. Okay, so okay, anyways, let's add more values to it. Let's say we have added 10. Update the graph. Still can't see it, so let's remove the not independent thing. Oh, wait a second. Yeah, independent. So you see, even with this small value of 10, n equals to 10, it is taking something in between. Okay, let's like zoom out here a bit. Let me just show you. It's taking something between 0.005 and 0.01 second. So you see, it's taking a bit more time, even with this small value of 10. Let's make it 10,000. So let me just remove this not independent thing. It will be better if I just delete the not independent thing, because it is hindering us the understanding of what is actually happening with independent thing. So I'm just trying to remove that, and I deleted the not and half. So at 10k time taken is, okay, let me just see. Let's increase it like crazy. Let's like this. So it is taking 0.5 seconds. Let's increase it more. What the heck is happening? So what should I conclude out of this? Okay, so I think in this video I failed because this is actually not working. Maybe because there is some problem. So what happens in these cases is that the JavaScript tries to minimize or optimize the time of execution of that very function. So it results into some inaccurate execution time representation. So right now I don't know what should I say to this. Let me just show you that video itself which this teacher made. Oh, I'm done, bro. Feel so sad visualizing. So have a look for this one, when the non-independent thing. So when you put 100, it is just here at this place. When you increase it and increase it, it just goes to 100 micron, and after some time it just goes constant. Okay, it just stays constant. But in the case of which is the independent function, the 5n plus 2 operation function, when you see the value keeps increasing, the time of execution just doesn't stays constant. You see, like here it just take maximum 180 milliseconds, but this for the same number of n it takes around 1.2 seconds. So if you increase n more, it will take around 3 seconds, 5 seconds. So you see that my that code didn't work. I'm not even joking, bro. I tried my level best to fix it. These are the number of iterations I have, prompts I've given to make it work, but for some reason I'm not able to make it work. But anyways, you got the point. Yes, the time of execution depends upon the number of operation a function has to perform. Anyways, with time we'll create a better app than this one, okay, than this performance tracker. Let's make it. For now, let me just end this video. Let's move forward. Ta-da.